Now I will discuss this problem here, problem number 2. Here you are being asked to determine the minimum force P to prevent the 30 kilogram rod AB from sliding. So you have a rod here AB which weighs 30 kilogram, and the contact surface at B here is smooth, means there is no friction, and the coefficient of static friction between rod and the wall here is 0.2. Now the question here is to find the minimum force P required to prevent the rod from sliding. So if you apply, if the force P is 0 here, the rod will probably slide down very easily, right? And if you want it to remain there, you have to apply an external force P here. Now the question here is, what is that force? And this surface here is smooth, surface at B is smooth, and at A you have friction with coefficient of friction 0.2. Now how do we deal with this problem? So if this is 3 meter and this is 4 meter, this will be 5 meter. And at the center of the node you have weight of the rod, which will be 30 g, 30 being the mass and 30 g being the total weight, the force due to the mass, the gravitational force. Now let's plot the free body diagram of the bar AB. What are different external forces? You have external force P acting towards right here, and you have weight 30 g which is acting downwards at the middle, and you have a normal force from the lower surface on the block, on the bar, which we will call that NB. And here there is no frictional force, because it's already stated that this surface is smooth. Therefore this surface, this is actually a rough surface with a coefficient of static friction 0.2, if I remember correctly. So that means you have a normal force from the wall on the bar. How much? We don't know, we will call it NA. And you also have frictional force here. What will be the direction of friction? We want to calculate the minimum force P required to make sure that AB does not slide. So the frictional force that will help us here will be the frictional force upwards. So the frictional force upwards will help the rod, will prevent the rod from sliding down, and hence that's the frictional force we would like to have, and its value will be 0.2 multiplied by Na, because frictional force is always mu multiplied by normal force. So that's all. Here there is no friction. Here we have accounted for both the normal force and friction, weight, external force, everything. Now what is the total number of unknowns in the equation? Na, Nb and P. Three unknowns, but we can also come up with three equations here, because this is what are the three equations? In 2D you have equilibrium equations in x and y direction of forces. So sigma fx is equal to 0, sigma fy is equal to 0, and you can also get a moment equation, which will give you a third equation. So equation number 1, net force in x direction 0, means P towards right, Nb is vertical, we don't need to consider, 30G vertical, we don't need to consider, and Na is the only other force we need to worry about. So P is equal to Na. Now net force in y direction should be 0. That means Nb upwards positive, 0.2 Na upwards positive, minus 30G is equal to 0. Minus 30G equal to 0. So that is equation number 2. Now equation number 3 will be the moment equation. We can take the moment equation about any point. So I will choose point B here. Moment about B. Why did I choose B? You can choose any point, but I chose B because you have three unknowns here, Na, Nb and P. And B is the point through which two unknowns are passing, B and Na. So the perpendicular distance between line of action of Nb and this point B is 0. Perpendicular distance between line of action of P and this point is 0. So when you multiply those forces with those perpendicular distances which are 0, the entire term will be gone. So many number of unknowns will disappear from the equation, and we will have only unknown Na in the equation. So I am trying to minimize the number of unknowns in the equation when I am choosing the point about which I am calculating moment. So if I had chosen this point, middle point, I will have three unknowns. P is line of action of P is this, so there is a distance between line of action of P and this point. there is a distance between line of action of NB and this point. There is a distance between line of action of NA and this point. There are 3 unknowns. So if I choose this point, NA will disappear, but P and NB will be there, 2 unknowns. But if I choose point B, I will have only 1 unknown remaining in the equation, and so I will definitely choose B here. You can also choose other points, you will still get the answer, but I feel like this will be the easiest way. So P multiplied by 0, NB multiplied by 0, those 2 are gone. Now 30G multiplied by perpendicular distance between 30G and point B. How much is that? Perpendicular distance between line of action of 30G and point B. This is something we discussed in the previous class. Can you tell me what is that distance? Perpendicular distance between 30G and point B. So 30G, this is the line of action of 30G. The perpendicular distance between that line of action of point B will be this distance, which will be 2 meter. So this multiplied by 2. And now that force is acting downwards here, so it tends to rotate the bar B in clockwise direction. So we will put a negative sign to that term. Now we will consider force NA. What is the line of action of NA? This is the line of action of NA. So this is the perpendicular distance between line of action of NA and point B, and that distance is 3 meter. So NA multiplied by 3 meter, and this force is trying to rotate the bar in anti-clockwise direction, and we will take it as positive. Now you have remaining force, this one. So the line of action of 0.2 Newton, 0.2 NA is this one. The perpendicular distance between this line of action and this point will be this whole distance, which is 4 meter. So 0.2 into 4 meter. Now what will be the sign of this one? This force is tending to rotate the bar in anti-clockwise direction. You can see that it's trying to rotate in anti-clockwise direction, which means this is again positive. So see, like I told you, Na is the only unknown in the equation. Now you sort of feel that B was a suitable choice for you, and Na is equal to P, and you are being asked to calculate P. So that's straightforward there. But you can also calculate unknown NB from this equation. Which is not a problem. Today I'm going to stop the class. It's 12:50, I think. This power failure is actually a problem which is continuously affecting the class. It's about 40 minutes only, but we'll stop. Okay.